Academy. Today we'll be looking at chemistry, paper 4, May, June 2018, Cambridge IGCSE. So without much ado, let's quickly begin. First question is substances can be classified as elements, compounds, or mixture. What is meant by the term compound? What is the meaning of a compound? Okay, a compound is a substance that is made from 2 or more elements. Since it's 2 marks, we must give 2 points. So a compound is a substance that is made from 2 or more elements. A compound that is made from 2 or more elements. Okay, so question 1A. We say compound is a substance that is made from 2 or more elements. Substance made from 2 or more elements. Made from 2 or more elements. That's the first point. You know, you must write 2 points to get the 2 marks. Okay? If you write only this, you get only 1 mark out of 2. 2 or more elements. 2 or more elements. The next point will be that chemically combined together. The next point will be, you know, you say that substances are made from 2 or more elements. You now say that chemically combined together. Chemically combined together. Combine together. Okay, let's move on to the next. So you get these 2 marks. Combined together. If something physically combined together, it becomes a mixture. It should not be a compound. So if whatever it is, atoms or whatever elements, if they physically join together, they will become a mixture. But if they're chemically combined, they become a compound. So that's the question for A. He said define what is a compound. So that's that you get the 2 marks. Now let's go to B. Let's go to B, 1B. Okay, we use our board to write. It's slower to write on the paper. So the second question, the B, is a mixtures can be separated by physical processes. Mixture can be separated by physical processes. Now, a sequence of physical processes can be used to separate common salt, that's the sodium chloride, which is your common salt, from a mixture containing sand and common salt only. From a mixture containing sand and common salt only. Now, give the other and the correct scientific terms for the physical processes used to separate the common salt from the mixture. So we give the order, meaning you arrange them which one comes first in a logical order, and we give the right scientific processes. Is that okay? We give the right scientific processes. The first one will be a salt mixed with sand. The first thing we do is to dissolve it in water. So we say the first scientific process will be dissolving the mixture. Okay, so the first one we say dissolving in water. So you dissolve the salt and sand in water. You know, when they mix, the salt will be on the water, will dissolve in water. Sand will not dissolve in water. So you're able to, next stage is to filtration. Okay, you filter the water out. The water contains the salt now, which will be the filtrate. The residue, which is the sand, we still use a filter paper. You use a filter paper. You use a funnel. You use a filter paper. You use this thing, collect the water. The water is the filtrate that will go through the filter paper. The residue will be the sand, will be on top of the filter paper in a funnel. So after dissolving in water, the next thing we have is filtration. The one I've just explained. You filter. Filtration is the next step. What you will do, scientific process that you will do in order to separate the salt from the water. The next thing is to crystallize. Okay? After filtration, you crystallize it so that you can get your salt bath. You heat. Okay? So that you can get your salt bath. Okay? So we say you crystallize or you evaporate. So we either say crystallization or evaporation. You evaporate, so to get the water to evaporate away from the mixture of salt and water, and then you say evaporation or crystallization. Evaporation / crystallization, because it's the same process. Evaporation, that's you heat it so that the liquid will turn to vapor and escape, and the salt will remain. We crystallize at the bottom. Okay, the salt will remain. So these are the three processes, scientific processes, that you need to carry out. Crystallization. Crystallization. So these are the three scientific processes that we need to carry out in order to get our salt back, in order to get our salt that has mixed with sand. So the first step is to dissolve the water. The second step is to filtration, and the third step is to crystallize. Okay, so these are the three steps that we need to take. But how do we now get the 4 marks? There are 4 marks. Okay. Okay, I think since they only ask for 3 steps, they will distribute the 4 marks on these 3 steps. Okay, if you list them, you get 1 mark. The 4th mark will come from if you give them in order, if you follow the correct order. For example, if you list crystallization first, and then you list dissolving, and then you list filtration, you still get the 1 mark. That's 3. You will mostly get 3 out of 4. But if you're able to arrange them like this in order, you get the 4 mark. That will be the 4th mark. So we go to the next question, which is the C. Okay. The next question is C, and is the boiling points of 4 different alcohols, A, B, C, and D, are shown. So alcohol A is 56 degrees Celsius. Alcohol B is 78. This is ethanol. Okay, ethanol boils at 78. I think the first one is methanol. Then we have C. Boiling point is 122 degrees Celsius, and D, boiling point is 160 degrees Celsius. A student suggests that the apparatus shown could be used to separate the mixture of alcohol. Okay, the apparatus shown could be used to separate the mixture of alcohol. Now here you have the fractional distillation. This is the fractionated column. Okay, this is the fractionated column. This is the beaker to collect the different alcohol as they reach their boiling point. And here you have the mixture of alcohol inside this flask. And here you have a cork to prevent the mixture or anything from escaping. Okay, here is the mixture of alcohol inside this place, and here you have a beaker or something, and here you have the electric heater to heat this substance, and then you put the hot water here to aid the heating. Okay, so this is what you have, and this is a condenser. This X. Okay, they want us to label to tell what this one is. This is a condenser, usually a limbic. We call it a limbic condenser. This is a condenser. Okay, so this is what we have. Now let's see the first thing that we ask. You see, apparatus X needs to have cold water flowing through it. Apparatus X, this one, needs to have a cold water flowing through it. Draw an arrow on the diagram to show where the cold water enters apparatus X from here. Okay, the cold water enters from here. So we just draw an arrow to show that the cold water is coming in from here. And okay. Okay, so that's the first one. Name apparatus X so that you can get the 2 marks. It's 1 mark. Name apparatus X. Apparatus X is a condenser, right? So we say this is C Roman figure 1. Apparatus X is a condenser. C Roman figure 1. Apparatus X is a condenser. A condenser is an apparatus that cools down any hot substance that passes through it. Okay, any vapor that is coming through it will be cooled down. That's why it's called a condenser. So what does it do? Okay, wait. I think this one, let's take a look at this. This one, we said, I think the cold water should enter from here. You know why? Because the cold water, we have to, the cold water goes in and spread to this side. Okay? So that it can count what is coming down, the alcohol that reaches boiling point from here, okay? You know the alcohol that reaches boiling point is coming from here. So the cold water should go in here. And the hotness should go out from here. The hotness should be taken out from here. And the cold water should come in from here, from the lower aperture here. Okay, sorry, okay? So this is where the cold water should come from. And the alcohol that reaches boiling point comes from here, travel to this place, and will be collected in this beaker. Okay, so that's that for that. Now let's go to C Roman figure 2. C Roman figure 2. It's a part of the fractionating column is missing. This means that the experiment will not work. Draw on the diagram the part of the fractionating column that is missing. The part of the fractionating column that is missing. Explain why the experiment will not work with this part of the fractionating column missing. Okay. Now, one thing that is missing is the stopper. The stopper, right? The stopper is missing, right? So we have to include that. Let's see the diagram again. We have to include the stopper, right? So the stopper is missing, so we have to include the stopper and also include the thermometer if need be. Include the thermometer and a stopper. Okay, so but on the part of the fractionating column that is missing is a stopper. Okay, to stop, the stopper is to stop if a particular alcohol has passed, or you have to stop it, and so that before the next one. So a stopper is missing in this regard. So we draw and show it. Now the next is we should explain why the experiment will not work with this part of fractionating column that is missing. Because if it's not there, gases and vapor will escape. The gases or the vapor, the alcohol eventually turned to vapor, will escape. So we say gas and vapor will escape if we don't have the stopper. So the stopper is to stop any gas or vapor from escaping. It's to stop any gas from vapor from escaping. So what is missing is the stopper, And what is it used for? Why will it not work if the stopper is not there? Because the gas or vapor will escape. Gases slash vapor will escape without the stopper. Will escape. Gases or vapor will escape. Okay? So that's that. For chemistry, it's only brief answers. Chemistry does not require writing a lot. Just brief answers. Okay? Now let's go to the next question. See Roman figure 2. See Roman figure 3. See Roman figure 3. It says, suggest why the Bunsen burner is not used to heat the flask. Suggest why the Bunsen burner is not used to heat the flask. Let's take a look at it. If you look, we are using electric heater. Okay? We are not using the Bunsen burner to heat the flask. You know why? Because alcohol can be flammable. Okay? The mixture of alcohol is inflammable. Okay? So Roman figure 3, we say the mixture of alcohol is inflammable. See Roman figure 3. Say mixture of alcohol is inflammable. Alcohol, or you can say the mixture, you may not even specifically mention alcohol, is inflammable. Is that okay? Inflammable. Okay, so that's that for that reason. We move on to Roman figure 4. See Roman figure 4. See has a lot of questions. See Roman figure 4. Okay, let's see what reason we have with the question, what the question says for Roman figure 4. A hot water bath cannot be used to separate alcohol C and alcohol D. Explain why. C and D. Wait, let's see if C and D. Let's see their boiling point. 122 and 160. So a hot water bath cannot be used. A hot water bath cannot be used to separate C and D. You can see here the boiling point of C and D exceed 100 degrees. No water boiling point is 100 degrees Celsius. So it can only be used for A and B. Okay, hot water bath can only be used for A and B. C and D, the boiling point exceed 100. So we cannot use a hot water bath for C and D. Okay, so what we need to write here is explain why. You get 2 marks, meaning we need to give at least 2 good points. You say the water bath cannot exceed 100 degrees Celsius. Okay, C and D have a boiling point above 100. So these are the things you write. So a water bath cannot exceed 100 degrees Celsius. Water bath cannot exceed 100 degrees Celsius. Cannot exceed 100 degrees Celsius. Remember the boiling point of water is 100. Cannot exceed 100 degrees Celsius. So you not specifically mention. Since it's 2 marks, you have to write 2 sentences. So the next sentence will be, you therefore say C and D has a boiling point above 100. C and D have, okay, this is plural, 2 things, have boiling point above 100. So I just write BP. I have boiling point, I just put BP. In the exam, write full this thing. I have boiling point above 100. Above 100 degrees Celsius. Okay, so you get your 2 marks for this C Roman figure 4. Now let's see, do we have a question on C anymore? Let's see. Okay, this is the end of the entire question 1. So here we get 13 marks, 13 marks. So if we're able to provide this short answer, you get these marks. So this is why chemistry is interesting. It's very brief answers. You just need to be familiar with the chemical substances and so on and so forth. Now let's go to question number 2. Question number 2, and see what we have here. Is a flerovium, that's FF, flerovium is an element. Flerovium atomic number is 114. That's the atomic number, which is the number of protons, and eventually also the number of electrons. Because the number of protons is equal to the number of electrons. That's why an atom is said to be electrically neutral. Okay, so the atomic number is 114. So flerovium with the atomic number 140 was first made in research laboratory in 1998. So flerovium was made by bombarding atoms of plutonium with atomic number 94 with atoms of element Z. Now the nucleus of one atom of plutonium combined with the nucleus of one atom of element Z, and then this formed the nucleus of one atom of flerovium. Now suggests the identity of element Z. It's just 1 mark. It means it's not a big deal. 94, 114. What's the difference? So you will say 114 minus 94. What do you get as the atomic number? We'll probably be able to guess which atom was bombarded with plutonium. Plutonium is 94, and flerovium FL is 114. The atomic number is 114. So what we need to do is to find the difference, right? To find the difference, I will be able to probably guess which element was bombarded with it. Okay, so you say, let's do the mathematics. 114 minus 94. Okay. 114 minus 94, we get 20, right? So which element has atomic number 20? It's as easy as that. Equal to 20. So which element has atomic number 20? Then it is that element that was bombarded with plutonium. So it's calcium. So calcium has atomic number 20. So Ca 20. The first 20 element, everyone should know it by heart. Okay, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorinium, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Calcium is the 20th element. So we should know this by heart. We should know all the first 20 elements by heart. Okay, so you see, you'll be able to. If you don't know, you use your periodic table quickly. Okay, periodic table is given in paper 4. So in the exam. So you see, this is calcium. So you just write calcium. So this is the symbol. This is the symbol, but the name you also can write calcium. Calcium. See, this is the element that was bombarded with plutonium in order to get flerovium. Calcium. Okay, This is the element that was bombarded with plutonium in order to get fleruvium. Okay, so that's that for that. Let's see the next question. So the A we've answered, calcium 1 mark. In which period of the periodic table is fleruvium? In which period of the periodic table is fleruvium? Okay, period is determined by the period. The group is determined by the outermost shell. The number of electrons in the outermost shell determines your period, but then your group. But your period is determined by how many shells the element has. So you can begin to do the mathematics if you want to do 114. The atomic number is 114, or the number of electrons is 114. So if electron is 114, 114, you can do your math in order to get it. The first one will be 2. First shell will be 2. So we have to find the number of shells. The second shell is 8. Third shell is 8. So this you do 8. The next shell is 8, and then 8. Okay, and then 8. 1, 2, 3, 4, 5, 6, 7. Okay, 8 times 6. 8 times 6 is 48. Okay, I think it will have to be in period. To be in period 7. Okay, to be in period 7. So we say period 7. To be in period 7. To be in period 7, okay? Okay, anyway, that's that. The atom will be in period 7. We can begin to count. We can look at periodic table, actually. This one you don't have to waste your time. Just open your periodic table and find fleruvium. Okay, if we go to the end of this paper, I think there is a periodic table. See periodic table. This is period 2. Period 1 is the one that has hydrogen and helium. This one, hydrogen and helium. This one is period 1. Period 2 is this one. Period 3 is this one. Period 4 is this one. Period 4 is this one. Period 5 is this. Period 6, period 7. So see period 7. Let's scroll. 114. See fleruvium. It's in period 7. You know, period 1 is here, period 2 is here, period 3 is here, period 4 is here, period 5 is here, period 6 is here, period 7. So fleruvium is in period 7. So you don't even have to waste your brain or your time to calculate. Just come and look for it in the list based on its atomic number, 114. Okay? So it's in period 7. So it's in period 7. Okay, now let's go to the next question. Now predict the number of outer shell electron in the atom of fleruvium. Number of outermost shell electron will be 4. The number of electrons in the outermost shell will be 4. Okay? Number of electrons in the outermost shell will be 4. Why is that so? Outermost shell electron. Will be 4. So if the outermost shell electron will be 4, that means my being group 4, right? if you want to know this, you go and check the group it is. Just now, you check the group. You check the group. Which group was the fluoride? If it's in group, this is group 1, the vertical arrangement down like this. Okay, this one is in the, it's we're supposed to rotate it, but this PDF. Okay, so this is group 1. This is group 2. Okay, the next group 3 is here. Okay, group 3 here. Group 3. These are transition elements. They are not in the groups. Okay, this is group 3, and this is what? Group 4. If it's in group 4, that means it has 4 electrons in the atmosphere. If it was in group 3, it has 3 electrons in the atmosphere. You don't have to. So answering this question, you have to use your periodic table. Okay, for the period and the group that it is, you have to use it. So if it's in group, if it's here, to be in group 5. If it's here, to be in group 6. Like this one is in group 6. This one with the atomic number 116. Nivanorium. This one is in group 6. Okay? So fluoridium is in group 4 because it's here under 4. It's in group 4 in the periodic table. So that's why we don't have to calculate it's in group 4, because since it's in group 4, the atmosphere electron is 4. The atmosphere of electron is 4. So you do that, you get the marks. Now let's go quickly. You get the mark. This type of question, you just use your periodic table to answer. You use your periodic table to answer these questions. Okay. So it's a predict the number of outer share electron in the atom of fluoride is 4 because it's in group 4. Now, 2 isotopes of fluoride 286 and fluoride 289. So they have 2 isotopes, 286 and 289. The nuclei of both of these isotopes are unstable, and they emit energy when they split up. They emit energy when they split up. Right? State the term used to describe isotope with unstable nuclei. Isotope with unstable nuclei, we say they are radioisotope. Radioactive or radioisotope. So they are radioisotope. If an isotope have unstable nuclei, we say they are radioisotope. So here we just write D, Roman figure 1. Okay, this one was B. This one was B, I guess. This one was C. Okay. Now we're in D. D, Roman figure 1. You say unstable, since they emit nuclei, radioactive nuclei, you say they are radioisotope. They are radioisotope. Radioisotope. So they are radioisotope. Say they are radioisotope. Okay? So let's go to Roman figure 2. So Roman figure 2, it says, what do they want us to do? Let's see Roman figure 2. Complete the table to show the number of protons, neutrons, and electrons in the atoms of the isotope shown. Okay, 286. Atomic number 286, we have proton 2. Number of proton will be 286, right? What will be number of proton? Okay, this one is giving their mass. Because this is same fluoride 114. So, what will be the number of proton? Will be 114, right? Proton will be 114. Here we have 114. This is their mass. The number of proton will be 114 because it's same as the atomic number. So here, let's make this table. Isotope, number of proton, number of neutron, and number of electron. So we say isotope, Here we have isotope. So here I will just, instead of number of proton, I'll just write proton. Here, number of neutron, I'll just write neutron. Neutron. Here, number of electron, we write electron. So we fill this table. Electron. Here, we have the fleruvium 286 and 289. 286. And here you have fleruvium 289. Okay, so remember the atomic number is 114. So you can write here if you want 114. Here 114. Atomic number. Remember, isotopes are elements. Are atoms of the same element that have the same number of protons but different mass number. That's isotope. Okay. So here, number of protons is the 114. Let's change our number of protons is the 114. Number of electron is, since it's just an atom, it's not an ion, it's same as also 114. Same as 114. Same as 114. Right? So what is the number of neutron? Neutron is 286 minus 114. The mass number minus the number of proton. Minus 114. (286 minus 114). Here you get 2. 6 minus 4 you get 2. 8 minus 1 you get 7. And then 2 minus 1 you get 1, right? So here you get 172. Number of neutrons is 172. Here, 172. And let's go to this one. What's the number of proton? Same, right? So we have 114. Number of proton is 114 because it's the atomic number. Electron will be same because it's not an ion. Since it's not an ion, electron will also be 114. Because number of protons equals the number of electrons. That's how an atom is said to be electrically neutral. The neutron is 289 now, minus 114. 289 minus 114. So we can do the arithmetic here. 289. I think it will be 175. Because if 286 minus 114 is 172, 289 minus 1 will be 175. Although let's show it. 289 minus 114. 114. 9 minus 4, you get 5. 8 minus 1, you get 7. 2 minus 1, you get 1. So this 175. Yes, 175. So you fill this up, you get this mark. You get this marks, okay? So this is for this. Let's move on to, because you get 2 marks for doing this. And let's go to the E. The E question says that is a only a relatively small number of atoms of fluoride have been made in the laboratory, and the properties of fluoride have not yet been investigated. The property have not yet been investigated. It has been suggested that fluoride is a typical metal. It is suggested that it's a typical metal. It is suggested that fluoride is a typical metal. So just two physical property of fluoride. If it's a metal, they are indirectly asking you to give two property of metal. Okay, so it's easy. They are indirectly asking you to give property of metal. So this is a question E Roman figure 1, right? 2E Roman figure 1. 2E Roman figure 1. So it says suggest the property of metal indirectly, because they are asking you to suggest the property, physical property of fluoride. So it means it has, like normal metal, it has high melting and high boiling point. Metals, they have high melting and high boiling point. High melting point, so I write MP. High melting point and boiling point, BP. So we just, for somebody's sake, it has high melting point and high boiling point, because they ask you for property of metal. It's a good conductor of electricity. You know, metals are good conductors of electricity. They are just asking you, since they told you it's a metal, just give the property of metals that you know already in your basic science. So conduct electricity. Conduct electricity. Metals, they conduct electricity, right? So fluoride, basically, we conduct electricity. And it's dense. It's hard. It is very dense. Metals are dense, right? They have high density. You can just say have a high density. Okay, let's write high density. High density. High density. Instead of say it is dense. High density. Okay. You can say conduct heat. It is malleable, it is ductile. They're just asking of the physical properties of metal. Malleable. Okay. It is malleable. It is ductile. All the properties of metals that you know. Malleability is the ability of it to be beaten to different shape. Okay, and ductility is to be ability of the metal to be drawn to wire. Okay, it is also ductile. Ductility is the ability of the metal to be drawn into wire. So you also give this. It's shiny, it's sonorous. All these are properties of metal. It is very hard and so on. They ask for 2 because it's just 2 marks. For 2 marks, you just give 2 points and you move on. Okay. State one chemical property of fluoride oxide. Fluoride oxide. Okay. Metal oxides are what? Basic oxide. Non-metal oxides are acidic oxides. So one property is that it's a basic oxide. It's a basic oxide because metals are basic oxides. They form basic oxide with oxygen. Okay, so we say this one, E Roman figure 2. E Roman figure 2 is that it will form a basic oxide. It forms a basic oxide when it reacts with oxygen. Because metals, they form basic oxide. Like aluminum oxide, like sodium oxide, they are all basic oxide. Acidic oxide like SO2, CO2, those ones are from non-metals. So it forms basic oxides. That's one property of fluoride. That's one property of fluoride oxide. Okay, so it's a basic oxide. So we move on to the next question. If there is, okay, I think we finished question 2. So we do the first 3 questions for the first part. So once we finish question 3, then the remaining question 1, question 2, Question 3. Question 2. 4, 5, 6. I think there are 6 questions. Okay. We do 3 for part 1 video and we do 3 for part 2 video. So let's do question 3. Once we're done with question 3, we end the part 1. Okay. Now let's go to question 3 because there are 6 questions. Okay, so our lecture will not be too long. Now let's question 3. This question is about iron. This question is about iron. Is 3 of the raw materials added to a blast furnace used to extract iron from the hematite are coke, hematite, and limestone. Name one other raw material added to the blast furnace. 3 of the raw materials added to a blast furnace used to extract iron from the hematites are coke, hematite, and limestone. Name one of the raw materials added to the blast furnace. Hot air. We add hot air when we're doing this. We add hot air. Question 3A. We add hot air, right, to the blast furnace. Coke, hematite, we say hot air must be added. Okay, in order for us to read this. That's that for this question. Let's go to the next question. You have to add hot air to complement the coke, hematite, and the limestone. Now, B, a series of reactions occurs in a blast furnace during the extractions of iron from hematite. A series of reactions occurs from the blast furnace in the attempt to extract the iron from hematite. Now describe these reactions. Include one chemical equation for the reduction of hematite and one chemical equation for the formation of slag. First of all, coke is burnt to form carbon dioxide. So we can write that reduction equation. Okay? So we write coke is burnt in air to produce B Roman figure. Question B. Coke is burnt in oxygen to form carbon dioxide. We say coke is burnt to form carbon dioxide. You can write it in words. I just wrote an equation for it. Okay, you can write it before you write the equation. You can write it in words. So coke is burnt. Okay, is burnt to form carbon dioxide. That's that part. Now the other part, carbon dioxide is reduced by more coke to form carbon monoxide. So the reduction part, carbon dioxide, you burn it with more coke to form carbon monoxide. Okay? CO carbon react with carbon dioxide to form carbon monoxide. So to get carbon monoxide, the carbon dioxide you have obtained, you burn it in coke, more coke. In place of more coke, you get carbon monoxide, CO. You can balance the equation. Okay? You can always balance the equation. Here, if I have 2 here, I have 2 atoms of carbon, which is 2 atoms of carbon on the left, 2 atoms of oxygen, now 2 atoms of oxygen. Okay, so this is what you get. Okay, so this carbon monoxide, we react with iron at the hematite. The carbon monoxide that we get react with the iron 3 oxide to form what? remember we want to produce iron to form calcium. We react with iron 3 oxide to form iron and carbon dioxide to form iron. React with this to form iron and carbon dioxide. Okay, we can balance the equation. There are 2 atoms of iron here, so I can as well put 2 here. You know, when you are balancing, you don't put any number here. Put 2 here. So iron is balanced. Oxygen is 4. 1 atom here, 1 atom here, 4. Here oxygen is 2. Right? If I make oxygen 6, 3 times 2, 6. So we find how we make oxygen 6 here. Carbon is now 3 here. Right? Carbon is 3 here, so I can put 3 here. I can put 3 here, so that my carbon is 3, and my oxygen is 3 plus 3. See, 3 times 1, 3, and then plus this 3, 6. Oxygen is already 6, so this is a balanced equation. So we use the carbon monoxide we get from here to react with the hematite, okay, to produce iron and carbon dioxide. So this is the first part, or we can use limestone. You know, when limestone decomposes, it forms lime. So is either we write this and we get our marks, or we write the equation for limestone. If we write it for limestone, we say limestone decomposes to form lime. It decomposes to form lime. Like how? Limestone is calcium carbonate, right? You have calcium carbonate. You heat it. Okay. During the process of thermal decomposition, it produces what? Calcium oxide, which is lime, slake lime, plus calcium oxide, like quick lime. So there plus CO2, carbon dioxide. When you break this one down, when you heat this, 1 atom of oxygen here will react with this calcium, become calcium oxide, and the remaining CO2 is this one. You produce this. Okay? So this calcium oxide will now react this calcium oxide. Okay, my pen. This calcium oxide that you've just produced will react with silicon dioxide to produce calcium silicon trioxide. Okay, and the purity in this case is the carbon. So these are other steps you can take. Okay, my pen is restoring. Okay. But I think this first one we've done is sufficient for us to get our marks. We just need to write the reduction equation and what they instructed us to do. They say write one chemical equation for reduction of hematite, which is the last one we wrote, and one chemical equation for the formation of slag. Okay, so we have done that. Now the slag to be formed, this calcium, the board is still taking time. Calcium oxide will react with silicon dioxide to form calcium silicon dioxide, to form calcium silicon trioxide. Okay? Okay, let's move on. My board is hooked up. So this one is 5 marks. It's a lot. See why you have to be careful. This type of 5 marks, if you throw them away, you will lose a lot. Now let's go to C, question C. Now the iron extracted from hematite using a blast furnace is impure. Identify the main impurity in the iron and explain how it's removed in the steel making process. Main impurity in this case is always carbon. Carbon is the main impurity, right? Carbon, I don't know if the board will write, still not writing, still a story or a connecting. Okay, the main impurity, we just state the answers. The main impurity is the carbon. How is it being removed? How is it removed? You blow into it, or you pass oxygen through the molten iron, right? You pass oxygen through it, then carbon dioxide will escape. Okay, that's how you remove it. It will react with oxygen to form carbon dioxide, which will escape from the system. Okay, so this is where we stop for the first part of our class. Thank you very much for joining us.